So I want my AI agent to collide with these items inside my environment, water, food, and money. And to do that, I reward my agent whenever he gets closer to these items. And to do that, I use this distance reward function. For instance, if the targets were water, I subtract current distance from previous distance to the water. The previous distance to the water subtracted by current distance. So if the current distance are smaller than previous distance, this would be positive, and so the value returned by this function are positive, so he will get positive reward. And yeah, so this is just by me encouraging my AI to getting closer to these resources using pure distance. But I thought maybe I could utilize the directions he's facing. And indeed, I've been feeding sine and cosine as direction as inputs to my neural network, but I haven't really been utilizing these as a reward system. So the goal is to reward my AI agent if he is facing towards the targets pretty perfectly. I mean, reasonably. Like if I want my AI to collide with water, he should be relatively facing towards the water, like not facing away from it. And I've done it by this function. It's just using a pure math, like using dot products, and this is just really hard to visualize or to understand. So I made a simple diagram. So for instance, if the AI agent is placed, so any, by the way, this is x, z coordinates because I'm using DirectX convention. So onto the screen is z plus, so towards this direction is z plus, and this is x plus. Anyways, if we wanted to compute a vector from AI agent to the water, looks like this. We just need to subtract each water's components from agent components. So this is 3 on the x coordinate, and this is 1 on the x coordinate. So 3 subtracted by 1, and this is 2. The same goes for z coordinate. So this vector, this equation is for this vector pointing towards the target, and this is just an example. And this equation is equivalent to this. So this just essentially computes vectors towards the target. That would be, the targets would be water, food, and money. And that was just an example, but next one would be more, this is more practical. So let's say, so this is how each episode starts. Agent starts at the location 0, 0 and facing onto the screen, facing towards Z plus, and let's say water is placed at 0, 2, and if we wanted to compute vector looks like this, we just use this equation. So this would corresponds to this, like I said. And after we computed the target vectors, we want to normalize these. And the reason we normalize it is because, as you can see, the dot product. So I take dot product here, and to take dot product, the equation looks like this, where if these length of A and B were 1, also unit vectors, this would essentially becomes this would vanishes. These would vanish, and it would just become cosine of angle between these vectors, and we want that. So yeah, I just normalize them, and this would be 1. So for instance, for this case, dx is 0 and dz is 2, and if we plug that to here, this would be 0, and 2 times 2 is 4, and take square root, that would be 2, and divided by 1 divided by 2 is half, and this is 0, so it doesn't matter. And if we divide 2 by half, or 0.5, this would be 1. So this target vector would become a unit vector, which is just 0, 1. Essentially same as this forward vector of my AI agent. So yeah, this is just purely to make the dot product simpler. And we take dot product, which looks like this. It's just essentially, it would be essentially just multiplications of x components and y components. For my case, y would be z, and these would be 0 because these are orthogonal vectors. Anyways, so for this case, essentially, initially this direction sign would be 0. So I'm assuming we are computing whenever for the first time, whenever the training starts, or whenever each episode starts. The direction is initially set at 0, and if we plug that to this function, convert it to radians, sine of 0 is 0 and cosine of 0 is 1. So this would essentially become 0, and 0 times 0 would be, so these would be 0, and this is 1, and dz is 1, so 1. So facing would be 1, and cosine ranges from -1 to 1. So the maximum possible reward from this function would be 1. And as you can see, this is the water and this is my AI agent. This is like ideal direction he should be facing. If he's facing this direction and water was here, so this is like the perfect situation. But this might not be. Obviously, this won't happen like frequently. Anyways, and I divide by this maximum steps per episode because on each episode the maximum reward is 1, and I'm doing this to stabilize my neural network. Otherwise, like if I give reward like 10 or 50 or like larger values, it would just unstabilize the neural network. I have experienced it with it. So, and also the rewards these are called proximity reward, which essentially means you're rewarding agent on each frame based on like tiny improvements for this case, like getting closer to items or facing towards the target. But so for these proximity rewards, this happens almost, this happens every frame. And if you maximum reward like 1 on every frame, this would also unstabilize the neural network, essentially, I guess, explode the gradients. And so that's why I'm dividing by maximum steps per episode. So imagine if this would be impossible, but imagine if this facing was always 1, and if I divide by this on each episode, at most the reward returned by this function would be 1 because of this, and that's really nice. And yeah, I'm experimenting with these clamping because cosine function also, so the smallest values would be the smallest value would be -1, and I could just reward penalize him by giving -1, but maybe I thought it would be more stabilized if I clamp to -0.1, but I'm just testing with these. So this was the perfect situation. But let's say if he was facing like this, in that case, the target vector would be this. This should be 0. This would be -2. So the forward vector of AI agent would look like this, and the target vector would be this 0, -2. And like I said, this is just essentially computing angle between a cosine of angle between where the AI agent is facing, essentially the forward vector, and also the target vector. I sorry. No, I just wanted to. I mean, like this. If he was facing towards Z plus and the target was behind him, so the angle between these vectors are pi, and cosine of pi is -1. So in this case, this function would return -1, although I'm clamping, so this would be -0.1. But if I was using this line, this would yield -1, essentially penalizing my AI because he should be facing negative Z. So yeah, so this is how, and yeah, and I'm using this function on all cases where if his hydration is not satisfied, like less than 99%, I call this function. And also if he's hungry, and yeah, and so on. And I feel like the way that his movement and locomotion has improved, like yeah, the way he changes his direction has, I think, improved. I'm This is just essentially, I haven't done any like matrix. This opinion is just from my pure observation, but yeah. So yeah, I think this is it for today's video, and yeah, thanks.